Welcome back. This is still Adam here talking to you about running Apache Hive on top of Amazon EMR clusters. In the last video, I did a pretty basic introductory coverage of the functionalities, features of Apache Hive, as well as the two different basic table types. So those are managed tables and external tables, as well as how to execute interactive queries using the Beeline client for Hive, like the Beeline shell. In this video, I want to pick back up and show a little bit more realistic way of working with Hive, and that's where we save Hive queries and data processing scripts to a file, and then submit those files or scripts to the Hive query engine via Beeline, and run repeatable experiments or repeatable data analysis jobs on top of Hive. So I'm still on top. I'm still SSH'd into my master node of the EMR cluster as the Hadoop user. And so if I pick back up where we left off on the blog post, I'm in this section executing HiveQL scripts to create a managed table and import CSV data. So I should have a clean database named TCI demo because I deleted all the tables in it last time at the end of the last video. And so in this video, I want to copy the same SQL, or very similar SQL to what I used earlier, and save it to a file that loads data, this time not from the HDFS file system, but from the local Linux file system into an external table of the same format, and then run the same query. And notice something, I'm doing this all in one file. So let me go ahead and use Vim and name it create blog posts.hql. Go into insert mode and I'll paste that script in there that I just copied. And just because this is going to bother me, I'm going to have to fix that indentation there. So again, when this executes, we're going to switch context to the TCI demo database. I'll create an external table here, and I probably should use the word external because it is in fact, oh wait, no, this is an internal table. I'm sorry. This is going to be an internal table that gets created, and then I import the CSV data from the Linux file system from the blog post CSV file that we'll take a look at again, and that I created last video, and have that inserted into this table. And then we'll actually see, once again, that the data is stored under that user Hive warehouse directory, and it should be like tci demo.db and then the name of the table there. And so after the table is created and then loaded, I do the same select, count, like, or sum likes for each category of the blog post that get imported, and that just goes out to the shell. So I will save that, and then just like how I showed in the last video, you can execute strings of SQL using the -e flag. You can do the -f flag for a file, and that will actually parse and ingest a file of scripts or a file of queries and execute that within the Hive engine. So we can see those actually happening right now. And here's the output. So the same output that we were expecting from when we were running interactive queries within the shell. And let's actually prove that the Hadoop file system underneath user Hive warehouse shows our database as well as the table. So we did in fact create a managed table through a pre-saved script that imported it from the local Linux file system this time rather than from the HDFS file system. Okay, so now if we look at this script once again, this create blog post HQL script, what would happen if I ran it again? Well, I used the if not exists construct for the create table statement. So, we shouldn't expect that we have any issues with running that again. However, what will happen when this line executes that says to import the blog post CSV file again into the blog post table? Well, I'll tell you right ahead before running it, it's actually going to append the whole data set to the end of the existing data set, thereby doubling or duplicating the content in the table. So I'll show you what that actually looks like here. We'll rerun that same file through the Hive query engine. And this time we see all of the total likes counts. Sorry, didn't mean to copy and paste that somehow. But the total likes actually doubled now, proving that the data did actually get duplicated. So I can fix that problem by editing my create script and changing this load line so that includes the keyword overwrite. So overwrite will overwrite whatever data exists beforehand with the totality of the blog post CSV file. So I'll save that, and this time when I run it, that file through, I shouldn't be seeing duplicated data anymore. And in fact, they're just the regular counts. They're not doubled anymore. So we know that it did actually overwrite the data with the new import. So the next thing I want to show is how to export data back out to S3. Or, sorry, how to query data from S3, and then after that I'll show how to not only query data from S3 but to export our results from our queries back out to S3. So to do that, I went ahead and nuked the blog post table once again, as well as the whole TCI demo database. And so I have an S3 bucket named TCI EMR demo, and I want to load this blog post CSV file to a blog post directory within S3. So every EMR instance should come pre-installed with the AWS CLI. And if you followed my original video on how to create an EMR cluster, we attached default roles which give it permission to use S3. And so I'll do S3 or AWS S3 copy, so CP, that blog post file locally up to the S3 bucket that I've defined in the inputs directory, the blog post directory, and blog post.csv, and it says it successfully uploaded it for me. So now I have a new script to create, and I'll name it create external blog posts HQL. And so this time I create an external table, not an internal table, but an external table. Same format. Again, row delimited, comma separated. And then this time local points externally to the S3 directory that holds the file we just uploaded. And then I run the same query that we've been seeing over and over now. So let's run this time with the Beeline client, or submit it to Hive with the Beeline client. And see if it does in fact give us the ability to query data directly from S3 using Hive on EMR. Okay, so we get our obligatory error there, but that's fine. It just does that when it closes down the session for whatever reason. And we see, in fact, it did return a result set indicating that we did actually query that data from S3 and got the counts that we would expect. So I have really kind of one last thing that I want to show you all, and that's how to submit one of these jobs or one of these pre-written scripts like we were just working with here. Use a concept called EMR job steps to automate the execution of this data processing step that calculates or sums the number of likes per category of my blog posts on the coding interface. But this time saves the output of that query back to S3. So it sources the data from S3, processes the data in Hive on Amazon EMR, and then saves those processed results back out to S3. And again, that's going to be accomplished with something called an EMR job step. So what I'll want to do is I want to actually exit from my server, exit from the master node there, and come back to my local computer. And so sitting here, I just have a video from the last video, my README, and then my key pair that I used SSH on to the cluster. And so I'll copy my script here once again. And remember, I'm locally on my laptop. I'm no longer on a server. And I'll name this new script create external blog posts EMR step.htql, and I'll paste it in. And this time, same create external statement that we've been working with for a while, but the location is a dynamic variable named input. And then my select statement is actually preceded by an insert statement. So it's kind of like a CTAS, or insert into type of thing. So this says insert in overwrite mode to a directory to a dynamically provided output, which again is going to be an S3 location that we provide to this script via the EMR job step, in row delimited format with fields separated by a comma, and then the same select count likes or sum likes over each category from the blog posts that we're loading into Hive each time. So I'll save that. Oops. And that's the content. It looks like it saved correctly. And we can see I have it sitting right there. So the next thing I want to do is I actually want to upload that file or that script that we just created to S3, the same S3 bucket that I introduced earlier, but this time to the scripts directory, and I save it with the exact same name as I have locally on my file system here on my laptop. So if I run that, it successfully saved it to S3 for me. And then is what I'll do is I need to create a configuration file that I'll use in conjunction with the AWS CLI to submit this EMR job step to my EMR cluster. So I will name this config file hive step.json. So as you can guess and see, this is JSON configured or JSON configuration. The type of the step is for Apache Hive. I'm naming it likes by category, and then should this job fail, I just want the cluster to continue on running, and then I feed it a series of arguments that get fed directly into the Hive script, or the Hive CLI essentially. So it says, okay, I want you to execute this file. So that's the file that we just uploaded. And then I have input parameters for a variable named input. So that was the dynamic input right here, saying where to read data from. And so that's the same input data that we had posted to S3 earlier. And then another variable named output, and tells it where to write the results to this outputs directory. So I'll go ahead and save this. And then I can use my AWS CLI to post it up. And then it tells me my job step back here. And then I can use this command to watch my job step execute. And so we can see right now it's in the pending state. Still in the pending state, so it's just waiting and preparing itself to execute. Pending still, it looks. All right, and now it's completed. All right, so let's pull down the data from that outputs directory, make sure it looks as we expect it. So it saved the file in this funny name here. And so, Hive works in a partitioning way a lot of the time when we work with real data sets that are more appropriate to use in Hive, not this simple like 5-line data set that we've been playing with so far. And so normally you partition out your results as well as your inputs, and so this just means like it's got the 0th partition. So if I cat out 0, 0, 0, then we see I got the same results that we've seen throughout the rest of this series on Hive. And that's pretty much it. So, last but not least, since I'm done with my EMR cluster for the day, I'm going to go ahead and terminate it. And that concludes my section on using Apache Hive on top of Amazon EMR. I hope you found this interesting, and stay tuned for more videos and blog posts in the future where I cover other technologies that can be ran on top of Amazon EMR. So thanks for joining me. Have a good one.